Another beautiful sunny day of me going about my business, wearing a mask, but the mask fogs up my glasses. Also, it's a pain in the butt to put it on and off. Oh, take off my mask. Oh man, that took like 4 seconds. If only it was like the Marvel movies where the mask just magically, went on and off all the time so you could see the expensive actors underneath instead of the stuntmen. If only I could make something that convenient. Oh wait, I should be able to do that. I'm me. Oh Jack, I want you to draw me like the star of Christopher Nolan's movie Tenet. Maybe someday in theaters. I think we can do this with 4 servos, like these little micro servos. We'll have 2 that open up like a nose portion, like that, and I think I might build fans into it too. See, the human head, or any mammal's head, your skull doesn't move, obviously. Your jaw just opens that way. So the top half of your mouth, including the top half of your teeth and the nose, always stays pretty much the same. Obviously the muscles move, but by and large it's pretty much the same. So what I was thinking was maybe we could have a servo on each side that would pop open that mask like this. And then below that we could have a ring that connects probably via neodymium magnets. We could put kind of like a diaphanous material underneath it. Now you can't really breathe through this stuff, which is good, but that's what the fans are for. And then you could have another set of servos here that would do, what was that, probably about 80 degrees rotation. So with the push of a button, the mask would open up and then you could like take a drink of beer, because this is Wisconsin. I remembered I have one of these things. It's the Sense 3D scanner. It uses the same kind of technology as the Microsoft Kinect. And I think I can still use this to get a mesh of my head, which I can then draw 3D parts around. The software says, what do you want to scan, a person or a guitar? Well, I'm going to go with a person and just my head. Let's see if I can screen cap this while I scan myself. Okay, 15 inches away. 3, 2. Oh no, lost tracking. It looks like a Grecian relief of like some mythical, like, man from the past. I think I have to keep my face in the center of it. Start scan. Lost tracking. Oh my gosh, what do I need? Like, this is going to take some time. Wow, this is very unflattering. It looks like I've been to the Cronenberg dimension. This is all future generations will have to remember me by. So you got the Michael Jackson nose going on right there. But assuming my face is symmetrical, which it should be, we might have enough. Really all we need is the bridge of the nose, because I have a pronounced nose bridge. But I think we have enough of the slope there. You can see it. And then my cheek. Okay, I saved it in 3 different formats. PLY, STL, and OBJ. I'm just faking it to come into Autodesk Fusion. I remember when we used this thing on the show, even with a static object, like something we had sitting in a table, we actually had to make a rig where you could rotate this around at a fixed height and angle, because it's really sensitive and you have to go very slow. So if you think you're just going to tricorder someone like this, doesn't really work. However, this does sense scale, so what I bring into Fusion 360 should be the correct scale. Okay, so this is the OBJ file. See, this looks better just already because it's monochromatic, although I kind of look like a T-1000 liquid metal Ben Terminator. Say, that's a nice bike. No, it's like I'm frozen in carbonite. The Mandalorian got me. Yeah, I think I found the issue. I imported it as inches instead of millimeters. And so if I go from like the bridge of my nose back to my ear, 3.9 inches, it seems a lot more realistic. It's more like 5.7. Of course, that was to my ear. It's not that far off, considering it cut off the tip of my nose. So yeah, maybe this is fairly accurate. So what I can do is I can basically make a shape. Well, if this subtracts, I can make a shape just around like the tip of my nose and the beginning of my cheek, and then I can 3D print it and see if it fits, and that'll tell me if the scale's correct. Now I know from experience I can't subtract a mesh from a solid object in Fusion 360, so I'm going to use Mesh Mixer here. Let's see, import, where was I? Marvelous mask. Okay, so the bust. And what does work is if you export both of these things, so I'm going to export the visor and the bust from Fusion, and then if you bring them into Mesh Mixer, well, okay, so you see that it does appear in the same place on the screen, so this might make my computer barf, but let's see. Oh god, it's been a while since I've done this. Okay, I checked YouTube and help me remember. So I'm going to click on the visor, then right-click bus, and then it gives me Boolean difference. And then I should see that. Let's see, let's unclick that and that. It's performing Annihilation, which was a really pretentious movie. It's like, oh, let's make Predator, but with Natalie Portman. Oh, and it's really boring. I mean, I like Ex Machina. Okay, there we go. We got a Geordie LaForge going on. All right, I'm going to 3D print that and see if it fits my face. Going to print this at the crappiest resolution possible, which is like 0.4 layer height and completely hollow. Doesn't matter, we just need to know if the shape's correct. Here we go, so we got like a little eyeball hole there. Let's just stick it in place. Yeah, it's pushing on my eyeball, but other than that, seems like a pretty good fit. It could probably come over the bridge of my nose a little bit more. Of course, that's also where I'm gonna have the connecting part. Yeah, it's like I'm Geordie LaForge of the opera. Right, yeah, I mean, I think this is probably close enough. And really, all we need is this part of the cheek, the sealed part, right?
Here's a view of the left and right. I'm just going to keep calling them mandibles. I don't care if that's not the right word. Now, I did a test. I know the servo can move it. I really only have to design this on one side, and then I can just mirror it. I have a test for the lower jaw here. It's got 4 total magnets. It might need 2 more. Let me just, let's see, set pivot point. Probably right about there. Yeah, so the jaw will just, well, act like a jaw. It should clear my chin, but probably go about, 50, 55 degrees. I want to go a little further, actually, so when I'm talking, I don't hit it. But it should work out pretty well. It looks like, well, of course, you can kind of see my ear here. So that servo is already getting pretty close to my ear, so I'd probably put the other servo over this one. And of course, the servo for the jaw is going to be in a different orientation. I took some photos of myself from the side with the mandible on. You know what? The jaw or jawbone, especially the lower jawbone in mammals and fishes. So, I mean, yeah, it doesn't just have to go down. I mean, the predator had mandibles. Mandible predator. Yeah, see? So if you look at the mesh, it has my ear way too far forward. This is actually a better representation. First things first, I'm going to figure out where to put this secondary servo. And it's going to be a slightly larger servo, which means I probably could add magnets down here. Actually, these things printed pretty quickly on my flash forgery, so I could just reprint them. It's no big deal if I need to add magnets. Yeah, see what I can do. I'm also have to think about how I'm going to attach this to my face. I'm probably going to have like a secondary glasses ridge here on my ear.
Okay, I went to the store. I got a cheap furnace filter. I can take this apart and use it for a filter. And then I got like some weather stripping stuff. This one kind of looks like what would be in headphones, so I think this would be cool. It's got like a dome thing to it. So, yeah. Here are the 3D parts that I printed. This is the left and right mandible, kind of like a predator. And it's got 3mm neodymium magnets on the bottom for the lower attachment, and then it's also got magnets here for this attachment. So my concern is, can this little servo motor actually separate it? And if it can, then I can increase the magnetic connection here. Now obviously, once you have this together and the bottom part, you're gonna have, what, 6 magnets connecting, which will be pretty strong, but I'd like each individual segment to also have a pretty good connection. Inhalation and exhalation fans. I've got a slit here where I can put a filter. I'll add that later. Think darkness will save you. I was born in darkness, molded by it. I don't even know what the sun looks like. It'd be like all those stock images of models that someone on Fiverr has been paid to put masks on. So this will go like that, and then the lower portion with the cloth will come up and connect to that. Okay, let's do a test. I've got the servo attached to the mandible. Just got a simple Arduino sketch going. All right. So let's mate this with the other side and get a magnetic lock. I can feel the motor straining a little bit to get away from the magnet, but it still manages to do it. You can probably see a little bit of a delay as it pulls away.
So what I'm doing here is I'm aligning these servos in space, as best I can. Oh wait, I can't get too close because there has to be room for my new favorite word, mandible, to open. So if this opens 55 degrees. Okay, yeah, that'll be fine. We're still not intersecting the upper servo. We probably will need to remove the other half of that arm, but that's not a big deal. All right, I redrew the lower jaw. I'm going to put some larger magnets in here just so it sticks better. I can probably keep the 3mm magnets in the upper mandible portion. Here's how the servo links. So I just mirrored one side of the jaw and then linked it in the center. All right, I'm going to print this up and see if it works. And yeah, there will be a stronger magnetic force here, but that's okay because we're going to have two larger servos moving this. So there's going to be a lot more mechanical force behind the separation. It should still work. Wow, this jaw barely fits inside of the Flash Forgery's printer volume, but it does fit.
All right, so we got those pieces, and then we have the jaw with the magnets. What do you think about those ads where they're trying to make it look like it's a blogger, but it's clearly fake? You know, they're like, oh, let's have this person talk about something in their bedroom that makes them look so authentic. So where's the servo in regards to my ear? I can't really see. I need like a bunch of mirrors. Or a cell phone.
All right, I've been working on the enclosure for the side servos. So I have the jaw servo here, which is a larger one. And I've got it countersunk into this circular thing. This is where the action button will be. So I'll just keep it symmetrical. I mean, it does stick out, but I mean, this thing's going to look ridiculous no matter what. So, you know, that ship has sailed. Then we have the linkages. I redid these with screws built in. You know, so I'll have to put this together in a certain order, of course. Yeah. So what I think I'll do is I'll print, this is in two pieces. I'll print these two test pieces and see if it works. And then if it does, what I can probably do is just add some like general purpose mounting screws so I can print it for reals. I guess I could, well, no, I want to make sure this works first. But then if it does work, I can reprint it with the general purpose mounting screws, and then I can basically figure out how this portion attaches to the ear clip or around the back of my head. So I'm just working my way back from my nose. I'm just working my way back from my nose. Blah, 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 blah.
All right, here's the mandible stepper in a piece of plastic. It's not really the final piece, but it's close enough. Here's the jaw stepper, and I put a tack switch on the bottom of it. That will be the system open command. Now, there's some sort of tolerance issue that I can't figure out, but whatever. Anyway, so this is going to be the activate button. I guess I could have one on either side. Why not? All right, so then, as I mentioned, tack switch behind the servo. So I'm going to cram the servo in here. Too tight, but yeah, that's what'll push the switch. So we got our servo like that. And then this, I guess this comes through here. Where else would it go? Of course, it's all magnetized, so probably all my tools are going to end up... Oh, I need to snip off the back of this anyway. Go into that long, dark night. I'm the Dark Knight. Are you? Where are the bombs? You think being a bombotologist will save you? I was born a bombotologist. Molded by it. I knew everything I needed to know about bombs by the time I was a man. Why did Bane, like, crash that airplane in the beginning? What was the reason for that? Was he trying to get the bomb guy DNA or whatever it was? I'm pretty sure it involved DNA.
No one cared who I was until I put on the mask.
Looks like we're having an interference issue right there. Okay, well, anyway, in the meantime, let's take this mandible. Now I'm just saying mandible over and over just to say it. The Mandibulolorian. Well, I guess I could go write checks to send off my taxes while I reprint this piece. That's sure to put me into a great mood. Now the button's working now. That's good. What did you think I would do at this moment? I printed this in a different direction, which means there was support material over the screw holes for the stepper mount. So I have to kind of find them with the drill. I dropped the sigh! Then it is gone. I can get it back! Raphael, unlike your brothers, you have tried to channel your anger, but you face this enemy alone. Splinter always talked like he was pinching off a loaf. Oh man, my wrist hurts. Time to cheat. Whoa! Go to your home. One of the mandible servos. What was that word I said all the time during that one video? Tines? I think I said, oh, that was the Atari Vagabond. Finally finished after 20 years. That video kept saying tines all over and over and over. This goes like that. Where'd the screw go? Oh, of course it disappeared. Probably stuck to something magnetic. And there's the other screw that stuck to something magnetic. I suppose I could hook this up to an Arduino and sequence it, even though, well, that definitely clicks. I guess the question is, can it pull it? Well, it doesn't take that much force to pull it apart. That wobble isn't so great. Of course, you know what they say, the tree that does not bend will break. I'm going to start with this fairly simple Arduino test. I attached this part to the servo with the magnetized jaw in place. And I'm going to remove that and just see if the lower portion, or the mandible I mean, sequences properly. Alright, let me reprogram it. As long as it opens enough for me to drink a beer, that's all I really care about. I mean, this is Wisconsin after all. You might not be able to hear it, but there's a little bit of friction when it goes to the open state. So I'm just going to keep experimenting with the degrees until I... There we go. You can't hear it whining when it's open. Oh, I see what's happening. See those socket head cap screws? They are intersecting the plastic sooner than I thought they would. So what I could possibly do is get some flush flathead size 2 metric screws and put those in instead. 80 seems to be about the close point, so I'm going to punch in 80 manually. We'll see if it closes up. Now I'm going to go back. I'm probably going to go 20. Let's see if it has enough force to open against the magnets. Again, there's going to be 2 jaw servos, so if one can do it, 2 certainly can. Yeah, no problem. Alright, I'm not going to do any stepping. I'm just going to go full speed. Alright, send in code. Oh, I forgot to execute the test routine. It was commented out. Oh, I got the sequence backwards. Oops. So it's like the mask like springs open. Surprise, Spider-Man! I can crush you like a bug right now. Something else I didn't take into account is the thickness of my fabric. I mean, you know, it's not that thick, but it definitely has thickness. So I'll just measure it. I mean, I'm sure the magnets will still catch through it, yeah. So I'll measure the thickness of this material, and then I'll just subtract that from the top surface of the jaw. There's a little bit of collision right there, but we can just change that in the print. Not a big deal. Give about maybe a millimeter of clearance. I added a JST connector, Japanese solderless terminal.
And I've got it hooked up to everything. The pinout is button, fan, sync, going into a transistor, mandible left servo, jaw left servo, ground, and 5 volts. So yeah, as far as the fan's concerned, the fan gets the 5 volts along with everything else, and then we sync its ground into a transistor's collector, and that's what turns on the fan. Okay, so I'm going to slice up the filter material and put it inside the mask. There's a slit actually to fit it right behind the fan. It's a little tight on the side of my cheeks. I don't think it's just because I have hair. I could carefully measure my face, laser scan it some more, or I could just hit this with a blowtorch. It's time for a PLA creme brulee. It's true because it rhymes. Perfect fit! And it's gonna be covered up by a cloth, so you won't even see the burn marks. Oh, I should. Now I need to assemble and wire the right-hand side of it. Then I'll have the full jaw section and I can move on to the ear clips. Okay, I've got this side built. It's a little easier since I already done it once. So let's bring the mandible in here. That sounds like a villain, you know, like that would fight Batman. Like, I am the mandible. Oh, I'm probably thinking of the Mandarin from Iron Man. And all the fanboys who were like, why wasn't the Mandarin a 1960s stereotype of a Chinese person in a modern era where the main goal of making movies is to sell them to China? Pretty good fit, even with my sideburns. What happens if I take off this mask? It will be painful for germs. This might be the dorkiest thing I've ever built, and for me that's really saying something. And my other thought is that there's going to be a linkage here. That's what these pieces are for. And it feels like, yeah, I got space between that and maybe something there goes around the back. In the back I'll have like a LiPo battery pack and probably Adafruit Power Boost 1000. It, you know, just works. And then probably a little Arduino. I have some custom 32.8 boards I can use. And the cloth, I guess I'll have to see how it turns out. The cloth is usually going to hang down like with some elastic here, or, well, there'll probably be like some sort of a band right there. Still have like kind of like a baffle below my chin, because I want to be able to open my jaw fully, and I think I can still do that. Let me just figure this out. Ah, yeah, I can. Next, I got to think about how it's going to clip over my ears. So I've got this brass rod. I'm going to bend it. Well, I guess I could bend it like my glasses to start. In fact, my ears could be different from one another. They shouldn't be, but they might be. That's pretty good fit. I think like right here, I can have a neodymium magnet, and then I can put a neodymium magnet in the cloth and then actually clip it here to seal under my neck. All right, so I'm going to take this. I'm going to scan it, make a bitmap of it, then take it into Adobe Illustrator, make it into a vector file, then I can take that into Fusion 360 and then design an ear clip around it. Hot off the 3D printer press. You don't even know I'm wearing it. Seems to be a good fit. Now to see how this connects to the linkage in front of it.
I'm printing another test of the earpiece. In the meantime, I'm going to go here, create a sketch, and do a little bit of an offset. So this can be kind of my friction linkage. This will allow me to, you know, adjust the fit on this. Okay, so the idea is that will link to the earpiece. So the earpiece will contain the receivership for this. Okay, before I go any further, I'm going to test this. So the basic idea here is there'll be two springs here, and that they push this down to make it interlock with this. So it'll be basically spring loaded. So, you know, it should hold in place unless you apply force to it.
Never actually made a clamp like this before. Don't know if it's going to work. I mean, it should. See how it goes together there. Let's see if I can load these springs without causing a spring explosion. I don't think we have to worry about this coming loose. I don't know if I can even get it in place. Darn. Oh, I cut the springs down. That was just too intense. All right, let's see if I can. I think this might work better. Come on. There we go. Obviously, there's going to be a cap on this. So what's probably going to happen is there'll be an upper piece which has the ear on it, and then it'll screw down into this on the top to enclose this. I'll print 2 of these, and then I'll continue on this design and connect it to the earpiece, and then I can go back from there. So basically, I've quite literally gone from my nose to the back of my head. It starts in my nose and it goes to the back of my head. The feeling grows. Yeah, you bet you never thought you'd hear a Kobe Calais reference on this channel.
Got the ear clip, and then here is the cloth magnet clip. So basically you can clip the elastic cloth edge to this. It will hold a magnet. And up here behind the ear I have this receivership. Basically there will be a 1/16 by 1/2 inch flat aluminum stock inserted in here. I drew it in millimeters though. And then that will wrap around the head. And the idea is, if you recall, you know, I put this to the base of my skull. So that should apply, you know, if the mask tilts down, you know, if gravity pulls the mask down in the front, it'll act like a lever. The back of it will go up and hit the base of my skull. And that's also where I'll clip the electronics. But I think what I'll do is this all measures up. So I will get these parts printed and built onto the main jaw piece, and then I will put the metal rod in place and get it to fit. And then once I have that in place, I will build an electronics box that fits in the back of the metal rod and wire it up.
Waiting for some parts to print before I can bend the metal, but in the meantime, probably going to drive it with this. This is a custom Arduino board that I made, basically to use up my copious supply of Atmel AT Mega 328P chips. Very minimalistic, has a surface mount crystal, FTDI header. So what we can basically do is take this, pair it with an Adafruit Power Boost 1000. These are always great. Should give us plenty of power. And very scientifically choosing a LiPo that is approximately the same footprint as these 2 circuit boards. I'm going to start on the left because I've been designing everything from the left. So we'll put this piece of aluminum in here, right? And then I will drill it out so we have a screw going through the plastic and the aluminum. That'll keep the aluminum in place. Hey, viewers in almost every other country in the world will be proud to know that I did this all in metric. It's not like Americans don't know what the metric system is. We just, you know, we have American football. He's completed a 3.7 meter pass. The ball is now on the 78 meter line. It's 4th and centimeters. Yep, you'll never get America to accept metric until you get rid of football, American football. Maybe possible, I think. You know, just like how network television and newspapers are going to be dead as soon as the boomers are dead. Sports is probably going to die with Gen X. I mean, the only Gen Xers who still have television have it for sports. There we go. So I've got this point here. I made a scratch on it with a nearby knife. So let's call this, let's call that centered. I do have kind of a big head. I mean, physically as well as mentally. Like I have to wear like large hats and stuff. So a lot of people, well, I know I've said this a million times, but a lot of people are like, oh, Ben just does everything with the computer. He's got all these machines. It gives him such an advantage. It's like, well, yeah, maybe, but you still have to do a lot of things by hand. The computer is just part of the equation. So let me grab my big shears that'll cut through that like tissue paper. How do aliens know what tissue paper is? Well, maybe they do, but they just really don't know how to pronounce it correctly. I need to find this curve. This won't fit in my scanner anymore, so I'll just take a top-down photo of it against a ruler.
Bent metal shape. I did an offset of 2.5 millimeters. That should be plenty for 1/16 inch metal, although we have to take into account it's bent, so it's going to be less accurate. I mean, this is an exact scan, so even if it's not symmetrical, it is what I bent. As you can see, well, it's pretty good. I mean, not bad for a human. Again, this will probably end up looking much smaller than I realized. So this is going to need a programming jack, micro USB, charging jack, and then an on-off switch. And then, of course, 2 wire egresses. All right, that's a good basis. All right, so I'm going to just extrude this out and make it into a clip, make sure it has the holes we need, then I can 3D print it, and then we can start final wiring.
This is my first print of the electronics box. I made an error with the thing that holds the switch, but I can use it to at least get started. I'm just going to put the Arduino and the power boost in the relative positions against this PCB. Okay, I'm just going to do some stuff. I'm going to grab ground from right there. I guess my hand is blocking the view. And let's bring this over here and give us basically just kind of like jerry-rigging a ground plane. The Power Boost 1000 is pretty easy to use. You just hook up your battery here, and then you hook up the enable line to your power switch, and that turns on this circuit, which will power up everything else. 5 up on this side, so 1, 2, 3, 4, 5. That's going to be positive voltage. Power Boost 1000, it comes with a USB header, but I don't know, I never use it for that. I always just use it to power random things. It's pretty handy because it's got the charge controller for the LiPo, and because LiPos are usually on average 3.7 volts, but they can go as high as 4.2. It also does the boost, which takes the LiPo's voltage and boosts it to 5 volts, so you can use it with electronics such as this. Power plane here, positive 5 volts. Just so we have something handy to attach to. Of course, I don't want to take up too much space because I still need to put in those 2 transistors. Just use a bog standard NPN for that. What was that 4401? There's a Culver's restaurant near here, and their address, they have like a sticker on the side of the building, their address, which is 4401, and always makes me think of transistors when I go there. Okay, I'm going to place the first transistor. I think I'll put it over here. Probably just use like the ADC lines as a general purpose I/O to control the transistor. I'm sorry. The emitters of both of the transistors will go to ground. So I'll just tie those together, see how I've got it laid out. We'll use ADC5 as one of the transistor controls. Reset switch, we don't really need to be able to get to that, so it's not a big deal. I should have wired that a little bit more elegantly. I spared no expense, except for the computer programmer that I hired, who apparently is strapped for cash. So I always save my snipped leads from things for exactly this purpose. I mean, services like Oshpark are great and they're pretty fast, but not as fast as just wiring stuff up by hand. That's what I say about a lot of things. Oh, I'm only going to build 1 pinball machine, or I'm only going to build 1 portable Atari, and then this little LED here is the low battery indicator. I think what I'll do is I'll just remove the one off the board here, because it's already hooked up properly, and then I'll just manually wire an LED that will stick out the side of the case to these spots, and that will be the low battery indicator. I thought about having the low battery indicator on one of the mandibles so I could see it with my eyes, but that would have required adding another wire, and I didn't have room for any more than 6. I go along, I will just mark what I've been wiring to each one of the pins, so when I go to program it, I'll know exactly what to do. Except for the parts where I got mixed up. Okay, this reprinted. Let's see if it fits this time. Oh, good. It does. Cool. It's probably flush enough. Alright, so that goes in like that. This comes out like that. That goes in like that. Oh, I've got the world's most expensive work stand here. Quick power-up test. right, I've got the heartbeat sensor on the Arduino and the blue light here. And oh man, down is on? That's kind of backwards. Let's switch that around. Okay, I've snaked the ribbon cables in from the main mandibles. That's all the wiring. Well, we'll see if it works, and then we can program it to fine-tune the settings.
Say goodbye to boring, flimsy masks that make you look like you're in a hospital movie. Okay, let's test this out. Please excuse my eyes. I did not get very much sleep last night. I was traveling. All right, so the default position is for it to be open. And then we can just cycle it. Pretty good fit, although I don't think it's necessarily quite consistent enough. This is a nice fit around the bottom of my jaw. Okay. Let's see how it is with my glasses. I actually have to go to the optometrist today and get these glasses fixed. Apparently they're still under warranty. Hopefully it doesn't matter. Apparently it doesn't matter what you do to them. They'll replace them. I'm actually going to see if I can keep the lenses from these, and then maybe I could use them for a further mask revision, right? Yeah, so works pretty well. It's very mechanically satisfying, like with the mandibles and everything. But I think, you know, as I did this, I was like, well, this is getting really cumbersome. We got this and all this, and it definitely has a decent amount of weight to it. Like, it doesn't feel super great on my ears. So I think what I can do is make a more elegant solution that'll have the same effect, quick redeploy, and maybe even a better seal here. Basically using a simpler method and just 2 servo motors. And I might actually rip out the brain box from this one and use it over there, because I think I'm probably, what am I? Oh yeah, I only have 1 power boost converter. I might have a spare, maybe. I was also a little concerned with the mandible, like people seeing my nose and getting scared of my face, right? So I put in some material there, although it's kind of cosmetic, and there's this groove here that I wasn't super fond of. I tried using some of that Silly Wink stuff to seal it, but what I think I want to do in my next revision is to actually have this be one solid piece and just come down. So even though split mandible's cool, you can't always rely on it to close completely. Like in this case, it's kind of going off the bridge of my nose. Good first attempt, but you know me, I like revising things over and over and over. The fans are a nice touch, although I think that might be a little unnecessary. Although if I redo this without the fans, I need to find a different material. This material is not very breathable. All right, well, there you go. It's my first attempt at an automatic mask. Let me know what you think in the comments below. And yeah, I think we're pretty close to 100,000 subscribers. Then I'll get like one of those things in the mail, I guess. I could like put it in my living room or maybe my basement or my bathroom maybe. I need more things in the bathroom. I need like more wall art in there. So yeah, I haven't forgotten about the followers of this channel. It's just been a while since I've gotten around to making a video. It's like one of those things, like I have a bunch of projects I'm working on, but I don't always have something start to finish that I can show a video on. But yeah, stay tuned and I'll make more cool stuff in the future. I designed this to come off. And that. Oh, I should probably take my glasses off first. You know, I thought about getting LASIK, but then I saw a video of the lasers slicing up your eyes, and I'm like, nope, 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 nope. That's not for me. No, I'm Clark Kent.